Hi, in this episode we're going to do a quick recap of the variables and how we can declare them. I just opened up the GoDev website and it's going to show me a couple of basic types. As you know, Golang is a type-safe language, and you always must define the type of the variable explicitly or implicitly. Just have a look at this description here. You can have different types like booleans, which is true or false, strings, integers, different type of integers, bytes, units, runes, which is basically a character or a Unicode character could be, or float, which is a real number, and complex numbers as well. I've just prepared the boilerplate code, what we did last time, and let me show you how you can define variables. And I have the boilerplate code ready, so I can show you how we can define implicit and explicit way to variables. First, we can use the var keyword. So I say var. I'm just going to use short names I cannot type really fast. So a, and I say int, which is an integer, which is a number. And let's print this out using the format package fmt printf. This is the formatted print, where I can give a string with placeholders, where I say value, and this %d going to mean digit, then type, this %capital T going to say type, a and a. It will display on the console the variable value and the variable type, and it's best to add the /n, which is a new line. So let's try to run this. Go run dot, and my variable value is 0 and type is int. But we need an explanation why it's 0, because in Golang, when you define a primitive type of variable, it's not a pointer. I'm going to talk about pointers later. Then these variables have a default value. And this default value, for example, for an integer is 0. Now let's try another type, and let's say string. For string, I have to use the s placeholder here. I'm just going to put that into some kind of quotes, just to make sure that we represent this as a string. And you'll see the value is nothing. Empty, an empty string actually, and the type is string. Let's try it for a float number. Say float 32, and I have to change it to f, which represents floating numbers. And if I run this, the value is 0.00. This is a default value, and the type is float 32. Also, we can add initial value for that. Let's try to run, and I 51.000 if it's int, and I'll go back to D. Then the default value is changed, and now it's 51, and it's type integer. If I say string, and I put it into quotes, and say hello, I change it back to string, then it will say the type is string and the variable is hello. Let's see how else we can do that. Instead of using the var keyword, I can see colon equals and hello. If I'm running, it's still going to say hello and type going to be string. If I say 10, let me change that to digit, then the value is 10, type is integer. If I say 10.3 and the value going to be a float, and I'm running it, it's going to be a floating point number. So what happened here? So I'm not going to define the type, but even though if I defined the variable, with this colon equals, and it's going to try to figure out what type of variable is this from the format, what it's following, the variable name and the equal. So just to recap, these primitive variables have a default value, which is usually 0 or empty string, and you can define with var keyword. If you define it with var keyword, then it's going to be the default value, or you can assign a value as yourself in the same line, and you can define this way, and in this case it's going to figure out from this what type of variable it will be. By the way, let's try to change this, and now say a equals 53 and print it again. If I say go run, it's going to be 53, but it's still going to be a floating point value. So it's very important, if I define the variable and it's already exists, I cannot use the colon again. It's already underlined because it's going to break. The variable is already defined, but I can change the value with a simple equal. And if I do that, the variable type cannot be changed anymore. Then let's see something else, the constant. And go back to the previous example, but let's say const instead of var, and a equals 51. This is going to be a type int, so let's change it to digit and run it, and value is 51, type is integer. Let's try to change this one. A equals 37. I immediately see there is going to be a problem, but let's try to run this, and I cannot change. Const min is constants, cannot be changed, so I define the initial value, but I won't be able to change it anymore. Let's delete that from here and put it outside the main one. Run it, and it still works. And let's try with var. Let's run it, and still works. Then let's try it without an initial value. It does not allow that. But what's the another main difference between these two variations? If you define it outside of the function, then it's going to be global. It's going to be globally visible within this package. If you define it inside a function, then it's going to be visible only inside the function. If I would create another function here, you wouldn't say that. Let's prove this. Define another function, call it d1, and define another function, call it d2, put the variable declaration outside. From the main function, call the d1. From the main function, call the d2 as well. And this should say print fmt, just print line, I don't care the type right now, a, and the d2 a. Let's run it, and it displays 50-50. Try to change in the middle. A equals 77. Let's run it again, and it's 77. So now this is a defined variable in the global scope, and if I'm trying to put that here, just going to break. It's not working anymore because we don't have variable a within these functions. In the next episode, we will see how we can group these variables into a struct. See you in the next episode. Don't forget to subscribe to the channel if you want to be informed when I'm uploading the next one. And of course, you can ask in the comment.